Welcome to The Gig. I'm Johnny O, and we're doing all things tech. Today I want to talk about GPUs and system buses. You can't talk about GPUs without talking about system buses. On my last video about motherboards, I talked a little bit about system buses, but it more relates to the GPU system bus I want to talk about. Now, GPUs, graphics processing unit. You have AMD, which bought out a company years ago, a Canadian company, and you have NVIDIA. NVIDIA no longer makes motherboard chipsets. As of a few years ago, I think Intel convinced them to stop doing that for whatever reason. But the GPU manufacturer, NVIDIA, used to make system chipsets, which was interesting. But for some reason, they've given up on that industry or that entire market sector. I think they were paid off. I think someone paid them not to make them anymore or something. GPUs. Now, you can't really understand how a GPU works without understanding how the bus system works on your system. So back in 1995, 3D games first started coming out, and we used to have up to 3 video cards in one computer. The high-end gaming machines had 3 video cards. We had something called PCIe, that's the predecessor to PCIe. We had PCI, the predecessor to PCIe. Now, later, I think it was 97 or 98, they came out with AGP, which is Advanced Graphics Port. It was just for graphics cards. You couldn't put anything else in it. Unlike the new PCIe, where you can put almost anything in it. It's just like a new PCIe slot. But the AGP port was only for graphics cards. Now, this is how it worked. We would have a system video card to just run Windows, run 2D games, some 3D games, but these cards did not have 3D effects capability. They were just a basic system display, and they might have up to 8 megs. A really good one would have 8 megs of RAM on it, VRAM. Really, it was for AutoCAD and this sort of thing. They weren't for running games. If you wanted to run games, you would get something called a 3D effects card. It was made by Diamond Multimedia, and they were called monster cards. And the first iteration came in 4 megabyte versions. That's it. So you could also run Sly. So single line interleave came from 1995, 1996 for the Diamond Monster Media cards, and they would be 4 megabyte cards. And you could get 2 of them. So you would have your main display for Windows, which I doubt would ever be over 2 megs. I had an 8 meg, but that was a special card, and I got a good deal on it. And then I had 2 monster cards in Sly. So I'd be using up to 3 PCIe slots, and the motherboard only had 4 PCI slots. I would be using 3 of them just for my video system. So when you launched a game, you could literally hear the card click on. You would hear ting, and the cards would click on. I had them in Sly, so one of the cards would draw the top half of the screen, and the other card would draw the bottom half of the screen. That's how it worked. Then they had Monster 2s, which came in 8 meg versions. So if you had 2 of them, you had 16 megs of video RAM. Whereas with the Monster 1s, you would only have maximum 8 megs of video RAM. So again, you would still need 3 cards. Now around 1998, 99, I think they were first introduced in 1997, but something called AGP came out. The reason they were able to make a separate bus just for video cards is because now they started integrating the cards into your main display, which means you just needed 1 video card. You didn't need these 3 cards anymore. The video card would actually have 3D effects chips on it, just like a regular add-in card. Before this, your video card for running 3D, like the first true 3D first-person shooter was Quake 2. And that would max out your monster cards, 2 of your monsters. That's what you play it on. Before that, I think it was software rendered like Wolfenstein 3D, the original Doom, that was software rendering. Now you get into hardware rendering with these monster cards, these add-in 3D effects cards. But now, by 1998, they're taking those 3D effects chips and putting them right onto the card with your main display. So they made a new port with more bandwidth called AGP. So now, by 1998, 99, it was widespread. You just needed 1 card. And some of these cards would have up to 32 megs of video RAM. And I think the really big ones at the time, 98, 99, had 64 megs of video RAM. I don't know anyone that had them. It was insanely expensive to get a GPU like this. By, I would say, 2005, the industry had teetered off, and they had some pretty good 1 and 2 gigabyte cards out there, and it was all in one. Now, by 2007, 2008, they came out with PCIe, which is PCI enhanced. Okay, that's what we're using today. And they've improved it 1 or 2 times since its iteration. But as soon as I heard that they were going back to PCIe or PCI with PCIe, I knew right away that that meant what that meant. Now they'll have SLI again. Single line interleave. That's when you can put more than one card into a machine and have them work simultaneously on the same game. So both cards run the same game. In AMD video cards, they call them Crossfire. In NVIDIA, they call them SLI, single line interleave. They're all single line interleave, okay? I believe up until a year ago, the SLI, the NVIDIA configuration, was slightly faster than Crossfire. Now, when you buy a motherboard and you want to run a high-end gaming system, the first thing you have to consider is your system buses, because some of these cheaper motherboards only have 2 or 4 true PCIe lanes. Now, with 16 lanes to each PCIe slot, you can have up to 8 in a motherboard. The X299 and X399 will have up to 8 full-speed PCIe slots. Now, that's the kind of board you want to put 2 video cards in. Now, with the GPU, the price is kind of an issue because these Bitcoin guys about 2 years ago, even up to 3 years ago, started buying up video cards. What they do is these video cards are chopped up into hundreds of cores. They're called CUDA cores in the NVIDIA cards. And what they do with them is they'll set up clusters of them. 2 dozen, 3 dozen. I'm sure some of these guys that do a lot of Bitcoin farming, I'm sure they have hundreds of them. Hundreds of banks of these clusters. And they buy them up, so you went from paying $500 or $600 to a really high-end card. Now, I think last October I checked, because I needed a new video card last October, they wanted over $1,200. $1,200 for a video card, which a year before or 6 months before only cost $500. So when these Bitcoin miners come in, they really distorted the video card market. They're not using them as video cards. They're using them as CPUs. That's all they're doing. To mine Bitcoins. And I didn't like it because simply they should make some sort of card or device just for their mining. I don't know what they could use. Obviously, they don't want to use full PCs because it's more expensive. But if you need CPU power that you can cluster, use a bunch of video cards. I guess that works. They're just trying to be cheaper than the CPUs, the AMD and Intel CPUs. And they want a good CPU, so they use the GPU basically as a CPU for Bitcoin mining. And I think the prices have now come down. You can get a really good card for $400 or $500 again. As the card supply went up, the price went down, and vice versa. As the card supply goes down, the price goes up. That's how all markets work. I just don't like these Bitcoin nerds coming in and buying our GPUs. Also, NVIDIA announced a program that if you're not using the GPU for Bitcoin mining, well, they're going to give you a regular retail price. That's another thing that they're doing. So these guys, when they want to mine Bitcoins, they'll go in, they'll buy 2 dozen cards. And instantly, the retailer knows that this is not for playing video games. I wish it was, but it's not. It's for Bitcoin mining. And they will be charged a premium for that. I think at one point that whole market will teeter off because they'll make some sort of device, whether it's a cheap video card or something like that they can use that's just as effective for Bitcoin mining, or a cheap PC of some sort for doing that sort of thing. Anyways, they cluster them together in big banks and they make Bitcoins from them. That's not happening now. So as retail gamers, we get our GPU prices back again. Now, What the GPU does is it takes over from the main system CPU when you run a game. When you run that game, you'll notice your screen goes black for a second, unless your PC is really fast and you don't even see it. It's just a flip. That GPU comes on, it takes over everything. The CPU on your machine will be running Windows in the back, and it will be running the AI for a game. The GPU will do everything else. You can get anywhere from a 1050, a 1060, 1070, 1080 for NVIDIA GPUs. The number one GPU would be a 1080 Ti. You can get it in multiple configurations. 2 gig version, 4 gig version, 6 gig version. I'm sure there's a 16 gigabyte version somewhere. What those GPUs do is they run on the PCIe bus, which is capable of 16 giga transfers per second. Okay, that's not gigabyte, that's not gigabit, that's a full gigabyte per second. 16 of them. So you have one card, it's pushing 16 gigabytes per second in pixels. If you have 2 of them, it's pushing 64 gigabytes per second of pixels. That's a massive transfer rate. That's the biggest bus on your system. Now, they also take part of that, and if you want to know in more detail, they also take one of those buses or 2 of those buses and they dedicate them towards M2 drives, M2 SSD drives, and they run them over a PCIe lane with massive amounts of bandwidth, which is fine. It won't affect your gaming. But if you're going to get a dual card system or a SLI system, a crossfire system, make sure your video card has the maximum amount of PCIe slots in it and the most amount of lanes. You're going to boot your operating system off of your M2 and you're going to play off 2 cards. Okay? Now, when you do that, it pushes your frame rate to the max. Now, the reason you want your frame rate to the max is because frame rate is life. What happens is, if you're in a game and you're running 60 frames a second, average, and then a bunch of enemies come along, like maybe 10 enemies, maybe there's an explosion, maybe there's 10 enemies in a vehicle or 3 vehicles with 10 enemies, that's going to tax your system. So your CPU performance is going to come way down. It's also going to have to draw a lot more graphics for those new objects in the game. So the performance drops. So if you're at 60 frames and you drop down to 30, you're definitely going to notice. Okay? You might not be able to whip your scope up fast enough. You might delay when you're throwing that grenade for 1 second. But if you have a really high-end card or 2 really high-end cards and your average frame rate is 200 frames per second, and this happens where you have 10 new enemies, 3 vehicles coming in at you, and you drop from 200 frames to 120 frames, or even from 200 frames down to 80 frames, you will not notice one bit. You just won't notice. And that's why they run these SLI cards. So when things get really rough and there's a lot going on in your game, there's a lot of objects, there's a lot of interaction, there's a lot of fighting, that's a lot of graphics, that's a lot of CPU. It will bring your system down to a crawl if your system isn't set up properly for that. How you set up your system properly for that is you must always have a dedicated GPU. In fact, you should always have 2 of them. Now, on a laptop, there are some really good gaming laptops out there. I can run some brand new games on those gaming laptops and they work very well. They will never work as well as a desktop with 2 GPUs running in SLI or Crossfire. They just won't. A laptop will never beat a desktop if a desktop is set up properly. It just won't happen. Desktop software and hardware is always better than any laptop. Always. Always faster. Okay, so your GPUs run on PCIe. You got to make sure that your motherboard can run those 2 GPUs at the maximum system bus. Okay, I'm John. This is The Gig. Subscriptions down below, arguments down below, questions, comments. I'll get to your questions, I'll get to your comments if I like them. If I don't, forget it. I'll just ignore you.